Hey, Tammy.
I'm muted. Hi, Christian. How are you?
Doing well. How are you?
I am, I'm making it. It's a kind of a barely making it, but it is, you know, on the right side of the dirt, as they say.
So
Are you
when
are you involved in the Rwanda trip that John's going on?
involved in the standpoint of getting them out the door, but I'm not going much.
Hmm. So there's a kerfluffle until they leave.
Yeah, which is like now. I'm gonna go to
No,
the
yeah,
airport. Yeah.
yeah. Well, cool. How are you?
I'm doing well. It's been kind of crazy week,
Hmm.
but nothing bad, just crazy, just busy.
Yes, yes, that is right. Well, I was nominally at NREL for the first 2 days of this week, but I ended up sitting in a tire store for half of one of those days. So there were a couple of unsavory things that happened, but they were survivable. I was like, grumpy, and then I was just glad, like I can handle this. I have the capacity to handle it. It is not going to bankrupt me like it would when I was 20, right?
Yeah, last Labor Day, we got a flat tire driving down to Ashley's family's place in southern Colorado. It is super hard to buy a tire on Labor Day because everybody else was. We finally got someone who would like get us in that day, but we sat for like 6 hours in
Yeah.
Firestone, like just like
Oh,
waiting.
aw.
Several of them just told us to come back like the next Tuesday. I don't know how you anticipate us
Yeah, what's the
doing
point?
that.
Yeah, and I decided not to drive on it like I was good for the first time in my life. But then as soon as I called a tow truck, it started snowing. So so it just, at some point you're like, okay, I have to let go. This is for my amusement. It is not for my productivity. Will said that he could not be here and wanted it recorded, so I am recording. And I will enable my screen sharing. I'm close to hiring somebody. She's not going to work full time at first. She has some things to transition out of. She's the one you did not meet, Christian. So I didn't get feedback from you, but it didn't matter. But thank you for your participation. And yeah, and I'm really grateful to the people who did meet with her. My postdoc, Radial, was in both or a couple of meetings too. Oh, you were in the meetings with him a couple of times. So yeah, that was good. Hey, Dom. Hey, Paul. Marilee, Misa, Karia, Allison. Hello, hello. And we're waiting on Jordan, I believe.
Yeah, I know he's over there. If he doesn't hop on in a minute. Saw him frantically making changes to his slides. There he is. Be a first for all of us to see what the slides are. Hey, Jordan. That was Jordan who just jumped into my office saying that his computer is doing something. So he'll be on in just a minute.
Oh, of course it is. Well, we can do a quick getting to know you unless Jordan is going to do one.
I don't think he had one planned. So
Yeah. Anyone have any brilliant ideas for a short one? or question that's been in your mind, like you really wanted to ask people?
I can do one that's similar to what a different group did this week. As people who've been in Colorado for at least a little bit, what is your go-to thing that you tell people they have to do when they're coming out to Colorado or coming for the first time?
Hmm. You gonna pick an order, Christian?
Oh, I really didn't have that much thought. Sure, I will start putting people's names in the chat. There's no chat. Chat is gone. I can go first and then I'll just call people's names. How about that? As I figure out. There's the chat. I know it's a bit of a drive, but I always tell people that Estes Park is worth the drive if you have the time. So that's the one I was starting to put orders in. So Cardia, I have you up first.
Yeah, no worries. I feel like it depends on the age group that I'm giving advice to, but I always say the mountains, there's somewhere like not too far, but it's called like Dinosaur Ridge, and it's like near Morrison, Colorado. So people who want to get like the outdoor feel, but don't want to go too far, it's like 30 minutes. Yeah.
I'll have to write that down, Karia. Thanks. I think I'm next. I think my go-to advice is to get lotion. Or I give it in a small gift bag if people are staying with
That's
me.
brilliant.
Next up is Misa.
Yeah, I haven't done a lot of exploring around the area, but I do think one of the unique things about here is the natural areas that exist. I think they're pretty easy access and they have some beautiful trails and animals, and I think that's what I'd recommend doing.
Yeah, so I'm probably vying with Paul for this, the one that we do. Because, but I'm first, so yeah. So we get people who are unaccustomed to the altitude and who complain about hiking. So if there's a significant amount of vertical, then it's hard for them. So where we take the newbies is out to the Bent Rock Trail at Red Mountain. And that's where I take the REU students to, because it's flat-ish. It's a short hike. It's like 3 miles or maybe a little more. And there's just a really stunning piece of it. If you haven't done it, I highly recommend it, and do it in the clockwise direction. It's a loop, because then you just really come on this striking formation at the end. And we will be taking REU students to that the first weekend in June, if anyone wants to join.
Thanks. I wrote that down because I haven't done that one. So I'd say our go-to is probably and if they're okay with heights, so that does factor in a little bit, is to take them on to do Horsetooth Rock, just because you get the great view, and it's just kind of, it sort of reminds me of in Titanic when they're like, I'm on top of the world, but you kind of, to me, I feel that way a little bit, that I don't want to fall off the top of the world, but it's just a nice hike. But Ellison, when you mentioned lotion, that reminded me, we typically, and we had a guest speaker this week from Florida, and I sidled up to her and I said, you are drinking a lot of water, right? And so that's the other
Yeah.
thing is like, drink water,
Yeah.
lots of water.
Yep. Yeah, my gift bag is a little thing of lotion, a bottle of water, and hot hands if they're coming in the winter.
Yeah, I would say similar to Karia, it depends on the age group. If they're younger, like Misa said, out hiking anywhere, any natural areas are really, really pretty. But I know when my parents came, we actually they don't do too much hiking, so we brought them up in Boulder. There's a little spot next to NCAR, the National Center for Atmospheric Research. It's got a really nice view. It's not hiking or anything. There's a little parking lot you can go to and have a good view of the city of Boulder, and then as well as the Flatiron. So we kind of took them there. That was a nice little spot.
And Tammy's right. She did at least partially take mine. I was like, well, the Red Mountain and the Red Mountain open space and also, but also the Soapstone Prairie Natural Area. And especially if people are up for it, getting out at least a little bit onto the Pronghorn Loop. It's long to do the whole thing, like 9 miles, and so a lot of people wouldn't be up for it. If they can get out on it a little bit, they might see the antelope running around, and so that's really cool. So I at least did have that as kind of a, a 1B in my thoughts. So when Tammy took Red Mountain, still had something. And I just want to kind of feel like everybody's saying we're going outside once we're hydrated, both inside and outside.
I think that leaves me. Am I coming through clearly? Is my audio? Okay,
Yep.
awesome. Yeah, I can't get my video to work. I have this Russian security software and they go so far overboard. Everything's locked down, but this is working. I hope I can share my screen. But my 2 cents would be just like Dom, the flat irons. I think they're awesome, and depending on the level of fitness, even climbing the first flat iron is doable and just an incredible experience. So good answers, everyone. Good stuff. Okay, so
Have any brewery folks on here, or I don't know what's going on there, or if everybody's just embarrassed to admit that they actually go to the brewery. Anyway, okay, y'all are thanks, Christian, for stepping up.
yes. Okay, so Dr. Larange and I have some slides that we've prepared, and it is going to be introducing you guys to the test bench, the hardware and software integration for testing. And I'm going to share my screen here. Hopefully it works. Start sharing. Okay. Looks like it is working now. I don't use PowerPoint often. Does anyone know how to do full screen?
Bottom right-hand corner, move over right there.
Slideshow. Awesome. Okay. So as I mentioned, this is we're making the test cart, and there are a lot of things that this cart needs to be and a lot of things that it doesn't need to be. But basically, it's the physical system that we can use to start testing of the control systems and kind of evaluating the software that we need, evaluating the hardware, and very early phase stuff. So I can't read anything. So what this cart needs to be is we want to test all of the physical items that we need to control, the inputs from the that great interface that Dr. Larange made, that screen that the user is going to interact with. We want to interface with the node that's outside that's taking the particulate readings and stuff, and then we need to decide what to do with those readings and how to control our fans and our dampers accordingly. This system needs to start the process of finding how quickly we need to respond to changes, and yeah, it's kind of like a test bed for the next generation of cart. Now it's very easy to start going down the path where you're trying to figure out like solutions to how it's going to be integrated into the home and how what size blowers we need and all of these details that don't really apply to the cart used for testing. Oh. And yeah, we're not looking to find any particular components for the final unit. We don't need to think about how this is going to integrate into the HVAC. We don't need to think about the different home sizes that we're going to see, the different pressurizations, leakage, anything like that. This is just to control our our items, and I'll show you what those are next. So yeah, this is kind of just really driving it home. Goals for the test bench. We want to verify the connection points that we need on the real system. And Carson will be kind of leading the charge on that. He needs to find out like what his code actually controls. And this will give us a safe place for Carson to make errors. We physically need to switch different mechanical devices on and off, and we need the general power requirements to switch on those systems. You know, we're not doing any high voltage stuff, but yeah, you can't just use any old relay or any old circuit. It has to be like AC rated and things like that. So we also are going to make like a proxy home. It's going to be like a small box that we can vary the leakage and we can vary the resistance in and out. So we need to kind of make a proxy house. And then also this test bench needs to be like a visual for everyone to come in and see and kind of just get an understanding of how big this needs to be. And, you know, once we see it, people can like be inspired, like, oh, okay, well, this is there, but maybe we need to change this and that. And just like a visual. So anyway,
Let me just
like
add one piece there. When Jordan's talking about a proxy house, we're literally just talking about a pressure vessel, something that we can pressurize, change leak. So we're talking a barrel on the large size type thing, with the idea that this would eventually integrate into things like the house of pressure, into the hopper on the roof, all of those things. But we need something to be able to capture pressure that we're not going to blow windows out of. We can't just have this thing blowing into open air to be able to capture the dynamics of pressure and control systems.
Yep, well said. Yeah. Now this is kind of just reiterating the sensor node that's going to go outside. We're going to be getting data from that. It's all going to be sent to the central hub, and the user is going to interact with that. There's going to be manual overrides, and specifically what the cart is going to be in our focus is this intervention node, and the flow of that. Okay, so at first glance, this blue vent right here is the return into the furnace. All this red stuff is like the blowers and into the room. And then strategically, there are returns throughout the house. And that is one of the two most obvious places that we can stick it. But it doesn't have to be there. Again, it's hard not to think about like where we're going to go with our final product, but this is just an idea of where it might go, or a similar path outside of the HVAC. Now, here, so this green section here, just picture a straw, and all of these systems are going to be basically in line. Do I have like a little laser pointer? Where can I? Anyway, I can't really show
your
you.
mouse.
Yeah.
Oh, very nice. Okay, so the test cart is extremely simple and basic, and that's kind of good. And it really comes down to these two items, this motorized damper that's going to open up to the outside and close off the outside when we don't need it, and this blower fan. That's kind of all this system needs. In the test cart, eventually we're going to throw in a HEPA filter or whatever filter we go with. But initially, to kind of get the controls and inputs out, we're gonna exclude that. So yeah, the air flows in, and then the second red box is this pressure vessel that we're going to make. This first manual damper that you see is going to simulate the restriction that you would see inside of a home's supply line. You know, roughly 1/2 of an inch of water column. Then the pressure vessel is just a box, wood, cardboard, doesn't matter what it is. And then this manual damper that we're going to use on the outside to control the leakage. So nothing crazy here. It's pretty simple, but this, you know, as far as we can tell, this is all that the system needs to like properly pressurize the house. Now, split up here, we have the hardware and we have the pressure vessel. And, I'll skip or I'll briefly, reiterate what the design goal is. We want to adjust the volumetric flow rate into the home or the pressure vessel to control the pressurization. And the initial approach, we're going to have two different options on how to do that. One, we're going to choke the air that's coming in via the damper. And then also we're going to have like a kind of a crude speed controller where we're just using resistance and it's not important, but we're going to control the speed of the motor. Now, later on, we can get a little bit more sophisticated and add a variable frequency drive. And then finally, we'll just do, like a productization, whatever the word is. And that's where we like specifically match, advanced controls. Now the pressure vessel, the design goal is to basically just mimic a home, the leakage and the resistance that you would see there. Kind of like I said in the last slide, it's just two restrictions, one upstream, one downstream. After we kind of get the controls that we need, we can throw it into the house of pressure or the hopper that's up here on the roof. And, the final approach is something that we would see inside of a home. These are all kind of, they work in unison, like the final approach for the hardware and pressure vessels. So, okay, these are just like details, not super important for just the big picture stuff, but the blower fan is an inline specific fan to kind of what we need to, yeah, it's just this particular type of blower and motor is important to have. But and then the air damper, and these two things, the blower fan and the air damper, that's the whole project. So we just need to control those well. And then this is the manual damper that we'll be using to restrict the airflow in and out. And then just more detail on the wiring.
Jordan, can you go back to, I just didn't get a good look at it, the manual damper. Can you explain?
Yeah, so
this,
yeah, so
okay.
specifically the iris damper is what we're looking for, because the alternative is a butterfly damper, and you can kind of see in this little image this.
I just haven't seen the iris before.
Yeah, so the iris is a little bit better about like precisely controlling our leakage. If you use a butterfly damper, you kind of like, when it's very constricted, there's a ton of control, but once it reaches like halfway open, it's kind of just like the floodgates are open. But yeah, this iris damper is kind of the manual thing that we'll just set. And that's what's going to be attached to the pressure vessel.
Thanks, Jordan. Maybe if you go back to your inline diagram, we can kind of walk through some hypothetical cases about what we're going to try and do. So the hope is you will fire this thing up. Carson's code will achieve, a very slight positive pressure in our vessel, and then we'll start adjusting that manual dampener to try and perturbate the system. Change essentially the leakage rates that we have going on, and see if his control system can react to that and get us back to slight positive pressure. In this scenario, kind of on the bench top, it's challenging for us to change the real world outdoor pressure. So our best facsimile of changing our differential pressure needs is by changing leakage. So the hope is that we'll go back and forth. We hit a steady state, we make a big change to the pressure vessel, and can the control algorithm identify that it's out of spec, adjust the flow, either through choking or by flow, modulating the flow rate, and get us back into our target positive pressure. The kind of big picture goal here is, before we attach it to something that we might break, we'd rather blow up some barrels with the control system than pop windows out of the house of pressure, destroy the hopper, or, God forbid, damage somebody's house. So we see this as kind of a step one of vetting our technology and the control. As well as then when we get to the point of starting to select real components, we'll just swap them in and out. Okay, we have a better idea of what our total blow rate is, total flow rate needs to be. Let's switch out this linear blower with the one that we want to put into the real use cases. Does that make sense? Anything else you wanted to cover, Jordan?
No, no, just kind of an introduction to just the process that we're going to go through. Yeah, I think those were the main points. There's definitely a reason to starting small and maybe buying something twice, then trying to match something perfect without really kind of any full understanding on how this thing's going to be controlled. So that's why there are many steps, and we're not just going to go for the perfect system just all at once. But yeah, if anyone has any bright ideas, or if anything is obvious where you're like, okay, well, it can't just be two items, a damper and a blower. You need, X, Y, and Z. If anything is obvious, to let us know or let me know, and but this should work.
We see this as being kind of a modular system that will hope to grow over time. We'll add complexity, we'll add functions and features, but I think from a technology standpoint, the challenge of this project is the devil in the details. And we need to start flipping some things back and forth, doing some control on hardware as opposed to just the simulation type pieces that Carson has done to date. And so we'll start with safe to fail type sets of experiments, and then we'll add complexity and components over time. I think we'll learn a lot about the type of responses that we need to be looking for, the type of errors in the code to not put ourselves into an unstable control loop, which I think is actually a pretty big risk with these homes. So.
Yeah, and just as far as like a time frame goes, once the parts come in, we're almost ready to place an order next week, but this is going to be quick. Getting this built and getting this designed and installed on this like mock pressure vessel, it'll be quick. So we're going to start getting data here within the month.
So just a
hopefully.
question, what size do you envision this being? I understand it's not full size or not anywhere like the House of Prussia, but in your mind, is it like tabletop or is it the size of an elf or the size of an ant?
Probably 3 to 4 feet would be my guess.
Yeah.
So we want ducting that is of a reasonable, realistic size, blowers that are of a reasonable, realistic size. All of those elements, just in a compact packaging.
Yeah. We're using 10-inch ducting. All of these parts combined will probably be about 3.5 to 4 feet long, all in line, and then approximately 5 cubic feet for the pressure vessel. We can kind of stack them on top of each other, but it would be really nice to have this on a rolly cart. It might be sticking out a little bit in front or behind, but yeah,
And
something that can fit through a door.
Are you planning to build it in the Airy lab or upstairs?
Upstairs as a starting point. Probably what we'll do, because this thing is likely going to be loud and annoying at first, so we'll probably do the first set of it on the workbench in the coal hopper on the roof, just because we won't bug people as we're figuring out all of these pieces. And then take it out that door and move it into whatever space we decide is the next test case for it.
Yeah. There were design decisions on why a 10-inch duct is better than a 6-inch duct for the airflow that we need. Like if that surface area that you see between the 10 and the 8-inch almost doubles. So we cut the velocity in half just by adding 2 inches in diameter. So these sizes are to like limit noise and vibrations and things like that. But yeah, should be really fun. I think that's all I got for you.
So Jordan, maybe I missed this. You have on there for the manual dampers that they would be set at a constant position.
Mhm.
But you're going to be changing it for different tests, right? It's not like you put it at one and then it never changes. It's within a test, it's set at a constant one. Is that correct?
Yeah, I imagine in the very early stages, we'd mimic just like an average cubic foot per minute loss, like 750 cubic CFMs of leakage. And then we would kind of make sure that we're able to reach, 5-10 PSI inside the pressure vessel. And then from there, like as we get a little bit more sophisticated, we can, during the test, the Raspberry Pi could be taking in different pressures, and we'll open up that iris a little bit and we'll simulate like someone opening a door. And then we'll have the fan react appropriately. But yeah, early on, we can keep the restriction of the like a home's supply line at a set value, the restriction of a home's leakage at a set value, and just turn things on and off. Then we can start messing with, oh, is there a big gust of wind? Is there a door open? All these different potential options, and kind of physically change things, and then the system should be able to like get us back to equilibrium.
Yeah, so the dampener in the middle, mimicking minor losses in the ducts, would probably be a setting per experiment. And we do lots of different experiments and different settings to mimic more or less different size homes, how much loss you have in your HVAC system. And the pressure vessel leakage is what we dynamically be changing throughout any given experiment to see if our control can actually keep up with it or not. Does that help clarify, Paul?
Thank you.
I think we are likely going to be really unstable controls for a while, right? There's a lot of feedback loop elements in a system like this. So our hope is that these first tests allow us to start tuning the control elements to balance rapid response with minimizing the risk that we get to an unstable point, because we can't have that unstable feedback loop in a real home. It's just not going to be a acceptable risk once we actually get into somebody's home.
Yeah, and I
Yeah,
think, sorry, go ahead, Paul.
I think it was Jordan.
Oh, sorry.
Yeah, no, after you, I just had
Well, now that you mention all these instabilities, I'm assuming that at some point it'll be useful to have somebody with control engineering background. I mean, maybe you have that, Christian. But people who look at the modes of a system and where it responds, or somebody to do that. That sounds like it's down the road. We certainly didn't build it into the Sapphires project, but it's out there, isn't it?
Yeah, it's something that we'll need to continually be looking at. We'll build upon the control system that we did for the exposure chamber downstairs, because those were 3 interactions, a push, a pull, and a delivery, all that were interacting with each other for the exposure beer cooler on the first floor. So we've done some of this before. We just haven't had the same magnitudes of signals we're changing. Quite a bit of the airflow and the pressure readings compared to what we had to do in the exposure chamber. And one of the pieces we're going to have to play with, and I think philosophically decided at a certain point is how fast do we try and respond, right? The utmost protection and the utmost efficiency for the system is rapid response, but that is also the most unstable, or the risk of becoming unstable, right? And so that's part of what we're hoping to see from these early test benches is, okay, we can live with a 5-minute response time if it keeps us safe, or, you know, we need to cut that down by an order of magnitude for us to feel like we're actually going to be effective from a intervention standpoint. I think these things are easy to think about and sketch out on paper, and drastically different sometimes when you actually start to see the systems running. 5 minutes can seem like a really long time when you're standing next to a piece of hardware trying to get it into control. So,
I think this is a great idea to make something that can fail,
yeah,
make it
and
fail.
that's part of the reason we're going with cheap parts, because it's not can, it will. I guarantee we're gonna blow some ducting at some point or lose some seals, right? That's just gonna happen. Also part of the reason we'll do it on the third floor where there's not tours going by for the first couple rounds of failure. Inevitably, it's when like the senior team of the building is going by that something blows up in the lab. So one of the things I think will be really useful as well, which we didn't talk about here, but it's kind of on the roadmap, is now that we're getting close to the control piece being ready to put on people's desks, is have some people come out and play with that while it's on the hardware and see what the feelings are. It's like, is this fast enough for the system to turn off? Or do we need to put a harder stop in our kill nodes and all of that for the user override elements? Again, even 60 seconds is a really long time after you've pushed the e-stop for something to still be running.
And at the end of the day, it's important to kind of keep in mind that we would make, like, it would be a success if our data is telling us that the inside air is clean. And even if we have really slow response times, which makes like failure less likely, you know, if we're reacting at 5 minutes, but the data is telling us that the inside of the house, the air remains clean, we're good. So yeah, starting simple, starting slow is kind of the goal.
Great. We're happy to go into more details, and I think there's some very specific pieces that we'll, you know, reach out to some people on this call as we go to the implementation piece. But we want to get some early feedback of, does it capture the type of information that different people would want? Does it seem like a completely crazy idea? Some of those elements before we do the final speccing and purchasing of parts. So I think specifically Paul and Misa will be reaching out to the two of you to see if there's some pieces that we can build in for future things that we want to do with the pressure or the filters. We may not do on day one because we don't want to trash a bunch of filters, but to allow your work to integrate when we get to that level of maturity in the testing.
Did I see that the fan that was a squirrel cage, Jordan?
Yeah, let me do.
Looked like it might be like a radon fan style inline fan.
So we have it is a backwards facing centrifugal fan that is inline. It's similar to a squirrel cage as far as the blower blades are concerned, but that sleek inline round ducting attachment is kind of what we decided to go with, because the squirrel cages tend to be more of like a 90-degree bend, and this gives us an inline axial positioning that we kind of need if we're considering this sort of right. So squirrel cage-esque at its fundamentals in an axial position.
Right, okay, yeah, so it really is like a radon fan.
Yep, that's exactly how they do it. Yeah, but
Okay.
this sucker can push some air. It's really special.
Yeah, that's what's so impressive about radon fans is, I mean, they're sucking on the ground. Not a lot of, yeah, they got to really be able to do well against a highly restrictive back pressure. So
Yeah, yeah.
yeah, that
Um,
makes a lot of sense. Okay.
and we're hoping to operate this fan between 40% and 85% of its maximum, like unrestricted flow. And that's what also makes this thing so dangerous, that if we all of a sudden let this thing like unleash its full power, it can blow out some windows. So yeah, we need to be able to break some stuff early on to dial this thing in.
It just came to mind that we probably should put a pressure relief port somewhere on our ducting here. But I could.
Where's the fun?
Believe
Cool,
me, when
guys.
a
Thanks
pressure
for
relief
listening.
valve goes off, it's also super fun, just in a lot less lose your eye sort of way. Than it's still terrifying, absolutely terrifying, but a little safer.
All right, guys, I'm feeling good about sharing all the stuff that I needed to share. We can pull a nooner if we like.
Any other thoughts or feedback before we'll kind of take this to the next step and send some more formal things around to a few of you, but appreciate the feedback.
Excited to see it. And hear it popping.
Yeah. It's gonna be loud, that's for sure.
Yeah.
These blowers are loud, can be loud. So,
I'll just throw out that I will be back next week. And then after that, I'm gone again for probably a week and a half. So if you want to do anything in person, let's get something on the books for next week.
Sounds good.
yeah, I think doing even a 20-minute backup just to make sure we're all on the same page and how these are gonna integrate would be great.
Yeah.
Jordan, can you take the lead on getting that scheduled?
Yes, next week. Sounds good. I'll give us some options.
Cool.
I'm looking forward a little bit, folks. I've continued to attend the Healthy Housing Coalition meetings that are every month. They're a group of people from public health departments and different housing interactions. They tend to focus on radon, secondhand smoke, and things like that. But we've been, I don't know if you remember, but we've been talking for a while about having them hold one of their monthly meetings here in Fort Collins, inviting some city people and having a little party. And so it was scheduled to be the end of February, which was like yesterday or Wednesday. And when Taylor dropped out, I decided that I did not want to organize something like that without help. So we spoke during the meeting on Wednesday, and then because of some other scheduling things with people being on maternity leave there, et cetera, it's now being pushed to the summer. But I think that could be a good target to have some things ready to demo, maybe make a little longer meeting, get it on the agenda well in advance, have people from the city of Fort Collins in. Not everything has to be working, but they can see some of the things that we're working on, maybe a couple of student posters as well, hint, hint.
Okay, nice. Cool. Well, if everyone's feeling good, I mean, I can talk your ear off about all the details of this, but there's no specific questions.
Yeah, I should say I made Jordan trim his slides down by like 40 minutes. So nice job, Jordan. This is the right level of detail for this group.
Yes, thank you, thank you. I'm an expert at rambling, but you guys won't get that today.
Darn it. And we don't have a topic for next week, as I mentioned. If there's anyone who has data to present, that might be nice to see. Yeah, I think people have filled in the weeks after spring break, but we still have gaps in the next couple of weeks. So do let me know if there are things that you want to talk about. Okay, thanks everyone. Have a great weekend.
Thanks,
Yeah,
Jordan.
thank you, everyone.
Bye.